In this one, we have a small WordPress instance that's currently connected to a MySQL database on AWS RDS. Now I'm pointing to an RDS instance, and I'm going to run a simulated workload on the backend on my RDS. So as you can see, I'm pretty much maxing out my database. So Mike, tell me what I can do.
Yeah. Well, let's go ahead and take a look at the metrics, because this is the RDS, just to see what the total load is on your RDS instance right here.
And it's spiking up.
See that? Yeah, it actually looks like it's spiking up significantly right now. Maybe we can go ahead and take a look on that WordPress server as well and see what the performance is on the application side, like how much CPU is being used.
Let me start the test again so I can keep the database load. Okay, this is my WordPress server.
If your database is nearly completely hosed and your application's almost completely hosed, we're going to have to implement some type of caching here. Why don't you go ahead and start to set up a QueryPilot cluster for this? Tanmay, actually, there's one more critical step too. We developed a WordPress plugin specifically for QueryPilot. What happens essentially is we need to rewrite some of the queries for WordPress specifically because they're deprecated, the MySQL queries, and we created a plugin that actually automatically does that.
All right, so we'll have a link for folks to go ahead and get this plugin. It'll also be available from our GitHub shortly. It's a very simple plugin, as Mike said. It takes literally 2 seconds to install. That's it.
Cool. So the cluster's been created. It came up. Plugin is installed. The only other step you need to do is just swap out your connection string inside of your application. So we need to basically just point to your QueryPilot cluster.
All right, what next?
That's it. You could just run the exact same test again, and let's see what happens.
All right, this is the same test I ran. And now I'm going to go to my RDS instance and let's see what happens. Is it not running?
I think you may need to just refresh.
No, dude, it's not running.
Oh, no, it is running, actually. You can see the requests are being served by your application. It's just that none of the load is going to your upstream database. It's been completely removed. So actually, there's nothing happening. So even if you go to the metrics tab, let's see if the CPU is still spiking over here. Yeah, see, so that spike was from before. We had gone up to 100% in the previous test. Now it's barely even on the chart at 1.7. So your database is essentially completely free to service requests. Let's see how much load even was given to ReadySet itself. It looked like it said, it's about 1.9 out of 14. So only 13% of the memory on ReadySet was even being used. And some of that is also allocated to other system processes. So it looks like ReadySet could have handled much, much more. And yet almost 100% of the load was removed from your upstream database.
Where is the bottleneck then? It seems like we should be able to push this a lot harder now, right?
We should. Do you want to go back and look at the CPU usage on the WordPress instance one last time?
Let me run the test again. Oh, the test returned more requests. I think this was like around 94, 95. That's a decent improvement without doing anything.
Yeah, right, so about 20%.
I'm going to run this again and let's see what's happening.
Wow. Yeah, so you can see now your WordPress instance is spiking to 100%, meaning the web server itself is struggling to handle that many requests, but your database is completely fine and ReadySet is completely fine. So actually, if you added more instances or you increase the size of your WordPress instance, web server wise, you would be able to send way more requests, and your database would remain stable, and ReadySet could handle significantly more load.